This video is for students who wants to better understand how to do the lower block cycles workbook questions from page 33 to page 34. And I'm here to help you today. Hi, I'm Mr. Long and I'm your science teacher today. Let's start with the first question. X has mass and a definite volume. Which of the following statements best describe X? I'm so glad to see these two words, definite volume, because this definitely tells me that X is an object that is either a liquid, because liquids have a definite volume, or this X can be a solid. A solid has a definite volume too. And I know for sure that X cannot be a gas. So these two words alone helps me to eliminate option 1 because it has gas, and option 4 because it has gas in it. I'm left with 2 and 3 now. Can it be a solid? Well, a solid has mass and a definite volume. Can it be a liquid? A liquid has mass and a definite volume. So I can't be very sure which one. Now, the word only here tells you that if you choose this, you are saying that X is definitely not a liquid. But you can't tell from this. How do we then differentiate between a liquid and a solid? Well, we look at the shape. Whether the object X has a definite shape or it has an indefinite shape. If X has a definite shape, then it is definitely a solid. If X has an indefinite shape, that means it is a liquid that can fit into different containers and take up the shape of the container. However, as question 1 doesn't tell us about shape, it only tells us it has mass, so we cannot choose 2. We can only say that X can be a solid or it can be a liquid. So the answer is 3. Question 2. A beaker is filled with 100 ml of water. When a metal block is placed into the beaker, its water level rises to 150 ml. So this volume here up to 100 ml tells us that this is a volume of water is equal to 100 ml. In this case here, we see the volume 150 ml and it has two things inside, a liquid and the metal. So this is actually the volume of the water plus the metal block. Therefore, to find out what's the volume of the metal block, we simply subtract away 100 ml, which is the volume of the water, from this, which is the total volume of the water and the metal block, to get 50 ml. And here some of you may get stuck, and as you see, but all these answers are in cubic centimeters. Don't worry, 1 cubic centimeter is the same as 1 milliliter. That means that 50 milliliters is the same as 50 cubic centimeters. So the answer for this is 1. Next question. There are two objects, X and Y, and are placed on a balance. This is a balance. A balance is used to compare the mass of two objects to see which has a greater mass, or do they have the same mass. If they have the same mass, like what the name suggests, it will actually balance and neither side will tilt downwards. In this case here, when X is placed on the balance and Y on the other side, notice that the balance tilted downwards towards the left. That tells us that X has a bigger mass than Y. So the answer must be 1. Next one. A cup filled with water is inverted into a container of water as shown in diagram 1. When air is blown into the cup through a straw, the water level in the cup drops as shown in diagram 2 here. What does it mean? Let this highlighter highlight and to show the air that goes in. Alright, as air goes in, it bubbles up and you fill up the air that's already inside. The more air that you blow in, well, air is a matter, isn't it? If air is matter, we know that matter occupies space. And the space inside here is only so much. But the more air you blow in, that means you need more space for it. So what happens? So the air that is increasingly blown in will take up more and more space, more and more space, more and more space. What was in the space before? It was the water. So what happens to the water? The water is being pushed out from this cup. That is why I notice the water level, which was here originally, the water get pushed out into the container. So that's why when it get pushed out, the water level drops. So let's take a look at the question now. Why does the water level in the cup drop? When air is blown into the cup, very simply, there are two parts to this. Firstly, air that is blown into the cup occupies the space inside the cup. But this answer is not enough because the question is asking about water level in the cup. And my answer doesn't talk about water level at all. So I have to continue to give more answer. So what happens when the air occupies the space in the cup? What happens is that it will push the water out. Alright? And the water level drops. These are the words that we see here because this is what the question wants. And the water level drops as the air pushes the water out from the cup. Like what you see here, air goes in, take up more and more space, and as it takes up more space, it pushes the water in the cup out. Therefore, the water level drops. Will the total volume of the water in the container change when air is blown into the cup? First question, answer is no. Second question now, why not? Well, simply, did the question talk about water being removed? No, water is not being removed. Did the question talk about water being added in? No, it only talk about air being added in. So if water is not being removed, water is not being added in, why would the volume of the water change? It would not change. So simply, no, and the answer is, as no water is removed nor added to the container, which is here, the total volume of water in the container remains unchanged. Alright? As no water is removed nor added to the container, the total volume of water in the container remains unchanged. And that's how you do it. Alright? Enjoy science. I'll see you in the next video. Goodbye.